All right, ladies and gentlemen, here are your notes for Thursday night. I apologize for them being as late as they are. Had some technical malfunctions at school, but hopefully you will still be checking your Edmodo and get this recording here in the next 15 minutes or so, and we'll be able to get your notes and be ready for class tomorrow. We're beginning a new unit. We're moving into Unit 2. And we're going to begin Unit 2 by a basic discussion of parent functions. If you're thinking you've heard the term parent functions already this year, that's good. You already have. It was one of our review topics as we came into Algebra 2. You already expected to know kind of what a parent function is, but you may not be aware of what the parent function might look like for different types of graphs. So that's where we're going to begin today. All right, your objective, the student will acquire a definition for parent functions and learn the different types of parent functions. These notes are for tomorrow's class. Tomorrow's date is 9/13, September 13th. Yeah, we got a Friday the 13th tomorrow. So go ahead and record your objective and your date. And as always, anytime you need more time to copy down the notes, just hit the pause. And when you're ready to go, hit play and move on. Okay, now here's your basic definition for parent function. You should already have it in your notes, but it might not be a bad idea to write it down again. The most standard unaltered form of an equation or graph is called a parent function. The first one we're going to look at is the quadratic, and we've talked about the quadratic already this year. You should have had it as in Algebra 1 as well. And the quadratic function is when you have one variable in the first dimension and the other variable in the second dimension. Probably already familiar with the fact that a quadratic function does graph a parabola. And the parent function for a parabola is going to read simply y equals x squared. Okay, in functional notation, it will say f of x equals x squared. But there's your parent function for the parabola. Now let's look at some of the characteristics of what a parent function, parabolic parent function is going to look like. There's your graph on the left-hand side. As you can easily see, it opens upward and it passes through the origin. I also provided an XY chart for you there, and as you can very easily see, the y values, the range is squared. That's why the equation says y equals x squared. The independent value gets squared, and that equals your y. Okay, so our negatives all become positive because when you square a number, negative times a negative or a positive times a positive, you end up with a positive. And that's how come all of our graphs, all of our points for our parabola move upward. Okay, the next one we're looking at is the cubic function. You may have played around with the cubic function a little bit, but probably haven't spent a whole lot of time yet talking about it. If you have one variable in the first dimension and one variable in the third dimension, then that is cubic. So our basic parent function for the cubic would read y equals x cubed, or f of x equals x cubed. A little bit of basic information here about the cubic. There's what a parent function of a cubic equation looks like on the left-hand side. As you can see, it kind of swoops up from negative infinity through the third quadrant, then cuts across through the origin, passing into the first quadrant, and then moves off to positive infinity. Okay, so you can see it opens upward as you move from left to right. It passes through the origin. And of course, now by our equation, y equals x cubed. If we take our independent value, our independent variable, and cube it, that gives us our dependent value. So 2 cubed becomes 8, 1 cubed becomes 1, 0 cubed becomes 0, and so on. One of the things that makes the cubic different from the quadratic is when you cube a number, you end up back with the sign that you began with. So if you start off with a negative and cube it, you still end up with a negative. Positive cubed still ends up being positive. The next graph that we're taking a look at is probably new to everybody. It is exponential. Okay, an exponential function has the form y equals a constant raised to the x power. We probably haven't run into this one at all, so probably going to be some new stuff. A constant raised to a variable. When you do this, you end up with a graph that behaves something similar to what you're looking at now. Okay. It may or may not start in the origin, depending, but it's going to come from somewhere close. And as you can see, the graph begins trying to move more along the independent axis, and then as it travels further, it begins to move more on the dependent axis. So it kind of begins with a horizontal trend, but then rapidly becomes more of a vertical trend. And as you can tell, it pretty much looks like half of a parabola. Okay, so maybe an easy way to remember it by thinking of it like that. The next graph, it kind of goes hand in hand with the previous one. This one is called a square root function. And as you can guess and see right there, okay, this is the result of taking the square root of a variable. Okay, so our parent function is going to be y equals square root of x, or f of x equals the square root of x. Now this one is very similar to the exponential as far as its shape is concerned. Okay, but you can see this one takes off from the origin and heads more vertical and then levels out and becomes more horizontal. So this one kind of has more emphasis on the dependent axis and then becomes more independent as it moves. So it begins vertically but becomes more horizontal. And one little thing to kind of keep a note of is square roots typically produce positive values unless there's something else going on around the square root. Okay, so these type of graphs, square root functions, do tend to move more towards the positive x-axis rather than the negative. Doesn't mean they can't, just would have to be something else going on in the equation. Okay, the final graph, I believe this last one we're looking at today, is logarithmic. Now this one's probably new to everybody. Logarithm is a type of a mathematical operation, just like addition, subtraction, multiplication, division, squares and square roots, uh, sine, cosine, and tangent. It's a mathematical operation. Okay, so we're going to get into this a little bit more this year, the idea of logarithms, and we're going to see a logarithmic graph. The basic function, the parent function for the logarithmic graph is y equals log x, or f of x equals log x. And log is the mathematical abbreviation for logarithmic. So here's what your graph looks like. It is not all that different from a square root graph, with the exception that it does not begin at the axis and then move upward. Okay, this one comes from negative infinity. And as you can see, the graph does cross the x-axis at 1, 0. That's a characteristic of the parent function for a logarithmic graph. Logarithmic parent function crosses at 1, 0. And as you see there, the shape is very similar to the square root function, except it comes up from negative infinity in quadrant 4, crosses the positive x-axis into quadrant 1, and then kind of levels out and heads off to positive infinity. Sorry, one more graph. I believe this is the last one. It's an absolute value graph. Okay, an absolute value function is a function, of course, that has absolute value bars wrapped around the independent variable. So y equals the square root of x, or f of x equals the square root of x. This one's an easy one to spot. Its graph is very distinctive. And basically what you've got is a graph that looks like it is deflecting or bouncing off of something. Okay, so since your negative values in an absolute value bar, the absolute value bars steal the positive or negative aspect of the value inside the bars. So you end up with a positive value coming out of the absolute value bars all the time. So there may be things going on around the absolute value bars, but the value coming out of the bars will be positive. So essentially what you have is a graph that is trying to do something, and then somewhere along the lines, the absolute value bars steal the positive or negative part of the graph. So it kind of does the same thing, the same behavior in two different directions. You'll get a better hang of it. I don't think I explained that very well, but you'll get the hang of it. But absolute value bars are really very easy to identify. Their shape is kind of unique. Okay, so those are the different functions that we're going to be working rather heavily with in Unit 2. So right now our goal is to know what a parent function is, and for these different types of graph to be able to spot the different types of graphs and understand their basic characteristics, where they are, where they begin, where they head to, things like that. So just spend a little bit of time studying that, and we'll see you in class tomorrow. Again, I apologize for the recording being kind of late getting to you, but hopefully you got it just fine.